We want to get it started on time. Hello, everybody. Good morning, good afternoon, good night, wherever you are. On behalf of NACA-CAIPHEN Fellowship Program, Dr. Archana Shrestha, who couldn't be here today, she's flying to US, and if you didn't know me, I'm Sadiq Shrestha. We'd like to welcome you to today's third of the 5 lecture series of this program that we have. As you know, we had scheduled it for September 9th, but due to unforeseen circumstances in Nepal, we rescheduled this lecture to today. So we'd like to welcome you all. Before we officially get started, few housekeeping. Please mute yourself. If you are not muted, then we'll be forced to mute. And if it's too loud, then we may have to, kick you out. So unfortunately, hopefully that won't happen. Fellows, if your Wi-Fi is stable and has the capacity, please turn on your cameras. If it's not, then we understand. We'll take questions towards the end. And also keep in mind, this lecture is recorded, and the edited version will be made available later this week. Okay. All right. I'm extremely happy to have Dr. Madhav Bhatta, who's going to lecture today. He's a good friend of mine, but that's not why he's here to lecture. I've known him since 2005, both at the personal level and the professional level. It's the latter, that's why he's giving the lecture today. Currently, he's a professor of epidemiology and global health at Kent State University College of Public Health. Actually, he is one of the founders of the program there. Correct me if I'm wrong, but I think he is the one of the founders of the program at Kent State University. He came to US in 1991 and received his undergraduate degree in biochemistry from University of Pennsylvania. Then he moved to University of Alabama at Birmingham, where he obtained his MPH in epidemiology and international health, and then also earned his PhD in epidemiology. He's trained as an infectious disease epidemiologist, but he's also an expert in epidemiological methods. He's a methodologist, specifically focusing on health issues among vulnerable populations, including immigrant populations, women, and children, both in US and Nepal. He and I also have a long-standing collaboration with SPV and cervical cancer projects with the NGO NFCC in Nepal. He also serves as a senior public health advisor for a Germany-based INGO, Back to Life EV, that works in women and children's health issues in rural Nepal. Dr. Bhatta, thanks for willing to provide the insights on how to present results and create tables and figures, which is one of the fundamental things in manuscript writing. So, Dr. Bhatta, the floor is yours.
You can see my screen, correct?
Yes, looks great.
All right. All right. Thank you again, Dr. Shrestha, for inviting me, and thank you for that generous introduction. I want to start by acknowledging the great NACA-CAIPHEN Public Health Fellowship program team with Dr. Shrestha and Sadiq Shrestha and Archana Shrestha, as well as Archana Pokhrel and Pratiksha Paudel for arranging this and the entire program, as well as this particular lecture. Also welcome fellows, mentors, and all the other participants today. And I want to acknowledge the previous speakers, Dr. Icha Basnet, who gave a lecture on IRB and overall overview of manuscript writing, as well as Dr. Bhanita Shrestha, who talked about abstract and introduction, as well as method section writing. So I'm going to refer to some of the content they presented because, presentation of the result obviously is, based on, the previous sections of a manuscript. So I want to thank them for setting up the groundwork for me to talk about result presentation today. All right, so I'm going to start with a broader overview of where the presentation of results or dissemination of the results falls within the research methods continuum. Obviously, as Dr. Busnet and both Dr. Sharma talked about, the fact that we start research at the early stage where we conceptualize and formulate a research question. We do a research because we want to answer a particular research question in public health. It could be as simple as saying, okay, what is the prevalence of a particular health condition in a population? Or it could be more complex, like if a particular risk factor is associated with an outcome of interest, right? So we start with conceptualizing and formulating a research question. Based on that, we design a study. A particular study type could be cross-sectional, cohort, case control, whatever study type, and we develop protocol for recruitment and data collection procedures. And then we go and conduct the study. Part of two major component of that is recruitment of the participants, obviously, because we conduct epidemiological public health research in human population. So each person is a unit of observation. And on them, then we do the measurements on various factors or the characteristics we're interested, both the outcome of interest or the health condition of interest, as well as the potential risk factors and other other factors that could potentially distort the relationship or the confounder, right? After we have that, conduct the study, have the data, then we analyze the data. And the type of analysis we are going to conduct is going to depend on the purpose of the study, the research question, right? So, and in epidemiology, public health, there are two major type of analysis we conduct. One is descriptive analysis, where we're describing certain characteristics, as well as inferential analysis, where you conduct analysis on your sample, then make some inference about that characteristic or situation in the underlying population. And then after we analyze the results, then we have to effectively communicate the result to the audience or the public or the other scientific community. Whole point of doing research is that it can be disseminated and potentially used for public health program implementation, or conducting further research to evaluate a particular problem in a population. So when you are communicating results, you have to think about two things. First is you have to know your audience. Who is your target audience here for your result? The way you're going to be talking about your result is going to differ if you're talking to a scientific community, other epidemiology, or public health professionals who are trained in research methodology, who can understand your lingo, versus if it's a general public that includes clinicians or other professionals who may not be in your particular field, public health or even epidemiology specifically. So they may not have the depth of understanding about research methods as you do, as well as the general public. Then you have to talk to them in a different way so they can understand what you are trying to convey. Obviously, it also depends how you are conveying that information. Is it oral communication? Are you giving a presentation to a community group, or even at a scientific presentation, or is it in a form of a report or a scientific manuscript? Scientific manuscript is what is going to be the focus of today's presentation. So to effectively communicate the results, you have to know what you are trying to report. You have to know what to report. And the second part is, how are you going to report? So for that, you have to know your purpose as well as the audience. What is the key message are you trying to convey? What is the point of your research? That should be the driving force behind how you are going to present your result. And again, what is the target audience? Is it the general public versus the scientific community? That's how you are going to tailor your approach. So again, oral versus written communication. So for today's purpose, I'm going to be focusing on the written communication, specifically a scientific manuscript. So as Dr. Basnet as well as Dr. Sharma talked about the fact that a research report has 5 or 6 elements. It starts with the abstract or summary, introduction, method section, which includes data collection, data analysis, and from there we come to the results section where you are going to present, what you found, and then the discussion section, which will be the topic of the next presentation in a couple of weeks. So I'm going to couch what was talked about in a previous presentation, as well as I'll go a little bit in the discussion in my presentation with the couple of slides on, that'll take us to the next week's presentation or next time's presentation. So what results to report when you're writing a scientific papers? Again, that is going to be driven by the research purpose and the audience that you are targeting for it. So it informs the type of the study conducted, the analysis performed, and the results obtained, the research purpose. And a scientific research section generally includes 3 or 4 sections. One is the descriptive analysis section, where you're describing the sample, description of the sample, what was the age or demographic distribution, various risk factors. And you're also going to have some measures of prevalence and incidence measure, or what proportion of the sample had the outcome of interest and various risk factors of interest. So you're going to provide information on both the outcome of interest as well as your risk factors, as well as the general demographic characteristics of the population of your sample to provide a context for somebody who's reading your paper are going to know, okay, this study, the underlying sample has this characteristics. And that is going to be important for a couple of reasons. One is when somebody is reading and they're reading another paper on a similar topic, they can compare the results found in that particular paper versus your, and say, okay, if there's a difference between these two, maybe it has something to do with the difference in the sample size. Sample type, rather the sample size. The second component of the scientific results section in a public health manuscripts, including what we call in epidemiology univariable analysis. And that term may be different in some other fields. They call the descriptive analysis as the univariable analysis. In epidemiology, univariable analysis is referred to as looking at the relationship between your primary exposure and primary outcome of interest, one-to-one relationship, we call the univariable analysis. And then you will likely conduct a multivariable analysis where you are looking at the independent effect of your primary exposure of interest while taking into account the effect of other potential variables, right? So the results section is going to inform the discussion section of the results, right? And obviously the results are going to be obtained from doing the data analysis. Because of that, I'm going to focus about 10 to 15 minutes on some of the approaches to data analysis in public health research. So it'll be useful when I specifically go to the tables, table 1, say, oh, this is the descriptive section, and then you'll know what I'm talking about. So, all right, so data analysis is the process of systematically applying statistical or logical techniques to describe and illustrate, condense and recap, and evaluate data. That's one of the definition of data analysis. In public health research and epidemiology, we primarily do quantitative analysis, not specific, not all the time, but my talk is going to be focused on the quantitative data analysis, quantitative data and quantitative analysis. So to do the quantitative data analysis, you're going to need 2 types of skill. One is you have a skills and knowledge, underlying epidemiology and statistical knowledge and skills. Okay. Oh, I need to calculate a prevalence, or I need to calculate mean, median, mode, or I need to calculate odds ratio, risk ratio. You have to know the theoretical basis of those. What do they mean, right? So you have to have that underlying skills and knowledge, and then you have to probably helpful to have a skill in some data analysis tool. You can, hand calculate everything or use an abacus, but, that's not an efficient method of doing. So you have to use a certain statistical analysis tool to get the results that you're looking for. And it is not going to be enough for you to just know the statistical package, because if you don't know the underlying, the epidemiologic and statistical concept, then it's not, you can't ask the data analysis tool to do what you need to be done. And if you are able to, kind of manage to ask or get something in the statistical analysis tool and it spits out the results, you're not going to be know if that result is actually correct or not. So you have to have skills in both the theoretical knowledge as well as the analysis tool. So when you are doing data analysis or in epidemiology, you're going to deal with two types of variables. And I'm talking about variables in the inherent nature of the characteristics, not how it is coded in the data analysis tool. One is the qualitative type of variable describing characters, and you categorize into different categories. These categorical variables are also called nominal variable. So these variables categories do not have an intrinsic order. For example, male versus female. One is not greater than the other. It's just male is a male, female is a female, or sex or ethnicity, or race or ethnicity. So the other type of qualitative variable you may encounter is what you call an ordinal variable. They also call order categorical variable. They have some natural order, right? Some rank order. Classic example is the Likert scale. You may have poor, satisfactory, good, and excellent. So there is some kind of a category. These are categories, but there's natural order to them. So why is it important to understand what is the inherent nature of the variable? Because when you do the data analysis, you may think that it may be stored as a numeric variable, but doesn't mean it is a numeric variable in its nature. So when you do the data analysis and for example, for sex, you go ahead and calculate a mean or average sex, your the data set may have coded sex, male as 1, female as 2, and then you start doing analysis and you find, hey, I have a mean sex of 1.5. That doesn't mean anything, right? So just because a variable is a numeric variable, stored as a numeric variable, doesn't make it so. So you really have to think about, and this is not a hypothetical. I've seen students present, results with a average sex of 1.5 or something, and that's useless. It's not interpretable. So know the inherent nature of the variable. Then the second types of variable or characteristics we have are the quantitative variables, where they take a numeric value. So they can be continuous. Basically, theoretically, a continuous variable can take any value. For example, blood pressure, body mass index. If you think about blood pressure, you always see a whole number, 120 over 70 or 130 over 80. But that doesn't mean that's the only, it's the limitation of the measurement. It could be 180.1056. We don't need to measure that precisely, but it can take any infinite number of values. Or it could be discrete, where it moves in a step. Whole number for birth year, 2015, 16, 17, and 18. So again, know the nature of the variable, because you are performing the right type of analysis. So you perform the right type of analysis for categorical versus a analytic, quantitative, a continuous variable. So analytic procedures that we use in epidemiology is descriptive analysis and inferential analysis. Descriptive analysis describes the sample, and it reports what may be the frequency, proportion, rates, or measures of central tendency. That means mean, median, mode, right? Or you can do an inferential analysis where you're testing a hypothesis, saying, okay, this is the prevalence of a health condition in my sample. Based on my sample, this probably, what is the likelihood, the prevalence of that condition in my underlying population being, that particular value. So you either do the hypothesis testing where you get the p-values, or you do what you call an estimation. You calculate the point estimate and the confidence interval around it. When you see, odd ratio is 2.5, 95% confidence interval 1.7 to 3.9, it's saying, well, the likely value is 2.5. It could be between 1 point, whatever I said, 1.9 to 3.6, right? I'm 95% confidence that probably the value lies between those values. So that's the inferential analysis part. And epidemiology, again, there are two types of study designs that we have. One we call a descriptive study design, where we're describing what you are finding, versus the analytics study design, where you are looking at the relationship between a risk factor and a health outcome. So a case control study, cohort study, and even a cross-sectional study where you're looking at relationship between risk factor and the outcome can be classified as analytic studies, right? So when you have your study, develop an analytic plan based on what is the purpose of your study, okay? So again, it all starts with what is the research question I'm trying to answer. Based on that, develop the analytic plan. These are the type of analysis I'm going to conduct, and based on that, conduct the analysis, and that's going to inform how you're going to present the result. Also inform how the results are going to be presented as well. Okay. So I think when Dr. Sharma, she talked about in the method section, she talked about, one of the things that you should be presenting in your result is, the method section includes the assessing the integrity of the data as well. You want to make sure before you go to the main analysis, you want to make sure that the data you have collected is valid and reliable, as well as you don't take care of the potential missing values, and that's what we call assessing integrity of the collected data. So after you go through that, then you're going to go through the descriptive analysis and assessing an association, and potentially going to do the subgroup analysis. Okay. Right. So in the descriptive analysis that I talked about earlier, you're just describing, what is the level of the exposure outcome or the key variables, right? Right. In the analytic portion, where you're going to be measuring association between your exposure versus the outcome, one-to-one relationship or univariable analysis. And then you're probably going to do multivariable analysis to look at the independent effect of the outcome. So you have a descriptive part, and then you have the association part. Right? All right. So once you do that, then you are going to have to present your data or the results in the results section in a manuscript. So let's focus on how do we go about doing that. So a results section in a manuscript has two parts. One is the text section, and the other is the data visualization, or the summary, statistical summary presentation methods. It could be tables, graphs, figures, diagrams, photographs, and different, again, what data visualization method you're going to employ is going to be, dependent on what is the purpose. But in epidemiology and public health research, tables and graphs probably are the two common methods that we use to present the data. So in the text section, when you're writing a manuscript, you are going to have a limited space, right? Most public health research, health manuscripts have a limitation about 3,000 to 3,500, at maximum about 4,000 words. The entire, introduction, methods, results, and the data and the discussion section. So text section is going to be about 10 or 15% of your manuscript. That's only going to be about 300 to 350 words. If you really need, you can stretch it a little more. So for a 3,000 word manuscript, 3,000 words to 300 to 350 words. So you really have to know how to condense everything in that small section. But you can use your tables and figures to put most of the information. Again, you do not have unlimited space or unlimited number of tables and figures. Most manuscripts limit about 3 to 4 tables and figure combination. Again, you have to figure out, okay, how can I present everything I want to present within 3 or 4 tables? So that's the broad framework you're going to be employing when you're trying to present your result section. So how to result report? Like every other aspect of the manuscript, it has to be clear, concise, and you have to present objective findings. Just the facts. You basically, it's a cut and dry. This is what we did. This is what we found. Our sample has 50% males. That's it. Short, clear sentences. And how you're going to present is should mirror the method section. Basically, what you did, what you found, right? And so basically go down to your method section. So this is what we did, this is what we found, this is what we do. So use the same sequence, because you're not going to be able to report anything that you didn't do. So, and you want to report everything that you did in your method section. So the basic structure would be, something about recruitment and response rate. How many people did you have? What was the response rate? And then you're going to have some sample characteristics, include demographic and risk factor characteristics. That's the descriptive part. And you're going to present results from your primary analysis, where you're going to have univariable analysis, one-to-one relationship, and then you are going to have a multivariable analysis table. And if you have done, you may present the result of a secondary analysis or any other ancillary analysis that you did that may not have been necessarily the primary purpose of your research, but as you start doing your analysis, you found some interesting thing. So you could potentially present that. Not every paper has to do that and present that. Usually results are written in the past tense, because you've already done the analysis. That's what you found. In fact, entire your manuscript should be in a past tense. Because you have limited space, 300 to 500 words, do not repeat the information that is in the table or graphs or figures in the text as well. Just highlight. It's a dynamic interplay between the text as well as the result and graph section. You're basically pointing, highlighting the key findings in your study in your text section, and ask the reader to go and look at the details in the tables and figures. So use the text to highlight key findings, as well as guide the readers to look at the details or further information in the tables and graphs. And tables and figures should be numbered in the same text, same order you mentioned in the text. So if table 1, if you label a table 1, then you're talking about the table 1 first thing in the text section. So don't label your table the multivariable analysis as table 3, and then you're talking about descriptive analysis in the first part of the text section. So order should be mentioned the same way in the text, as well as the numbering should match the ordering. So how to report results section? Use a consistent pattern or the same order. So if you are presenting statistics first, exposed group, you started talking about that, do that, and then talk about the statistics for unexposed group. So throughout, so be consistent. Don't go jump from one one group to the other. So when a reader is reading through your paper, they basically know, okay, this is what he or she is talking about, the author is talking about, rather than them having to go to different sections for different things. In public health and epidemiology, especially, we always provide the effect size or magnitude of the association. That is basically the odds ratio, risk ratio, prevalence ratio for the analytics epidemiologic study. What is the magnitude? If people with a certain characteristic have prevalence of 10%, another characteristic have 20%, and then the difference between the relative difference between them is 2, 1, 20 divided by 10. So that gives you the magnitude of association is really important, rather than just giving the oh, one group has higher versus the lower. Okay, and also present the 95% confidence interval. And in epidemiology, public health, we don't usually report just the p-values, results with the p-values. We prefer confidence interval as well as the magnitude of association. Use consistent and meaningful decimal for reported findings. So I get that question a lot. And how many decimal figures should we present? 2, 3. Normally, one decimal figure is fine. 20, because if you think about it, the unit of observation in public health is one person, right? So if you want to say, okay, what is the prevalence of a disease in a population, 19.2 should be fine, right? 19.2345, going to more than one decimal place is not that meaningful, really. But if you're reporting the magnitude of the association, 2 decimal places better, odds ratio, risk ratio. Two decimal places better, because if you think about it, odds ratio, risk ratio have values from 0 to infinity. So the values between 0 and 1 are basically small. So they're really squished in. So if you actually just present to one decimal place, the effect size can be misleading. Okay. When you are reporting the measures of central tendency, that's mean, median, when you are summarizing a descriptive, a continuous variable, report the appropriate measure of variability. That means standard deviation, median. If you're reporting median, interquartile range, make sure that you report those. Always present absolute number or frequency as well as a proportion. When somebody is reading, absolute numbers are not easy to interpret, because you need to know what is the denominator. So proportion is always better, is the number you end up comparing. Okay. So I'm gonna, in next few minutes, focus on how to develop tables and how to present tables and figures and graphs. Okay. So again, go back to what is the purpose of, what are you trying to present? Know the purpose. That is going to drive, what kind of table are you going to present? What are you going to put in each of those tables? Okay. Make sure that each table itself, or graph or figure, I'm going to just use the term table, but any other, it applies to all the other modes of result presentation, should be self-explanatory. That means when the reader is reading your table, they should not have to go anywhere else in your manuscript to understand what you are trying to present. So everything should be in the table, right? The labels, headings, the labels, the titles should be descriptive enough, what, who, when, and where. So it should be descriptive, but it should be succinct as well. So writing a table title is actually a really it's a skill. It takes a little bit of a time. And again, when somebody's reading a table, they should not have to say, okay, what are they trying to say? It's what is this abbreviation? Or for example, do I have to go back to the text to understand what these term means? No, everything should be contained within the table. Avoid redundancy. right? And the goal is to achieve clarity and efficiency. So don't put a lot of unnecessary information in the tables and graphs and figures, right? Or there may be statistics, for example, p-value and confidence intervals give you the same information, so you don't have to report both of them. Okay, so be careful about what you're putting in the table. Always ask, why is this important for me to put in? What is this adding to it? Is it really necessary? Sometimes it might look good to have a lot of information in the table, but not really. If it's not serving any purpose, don't put it in there. Okay? So avoid redundancy both within the table as well as the text of the results section. Okay. Always specify units of measurements, right? Again, if you say age, tell the reader what you measure age in years or month. So again, that's part of the self-sufficiency or self of a table. So the reader actually knows what are you talking about. They present the data parsimoniously. Again, don't clutter your table. Only put the most important information. One of the things I've seen is, in Oz, if you do a multivariable analysis and logistic regression analysis, for example, you're going to get what you call a beta measure, and and if you exponentiate that, you get an odds ratio. So you don't have to present the beta as well as the odds ratio. Just put the odds ratio, because the beta measure is basically the intermediate information. So again, don't be parsimonious. Only put the useful information so that the table is clear. Table, graphs, figure, they should be visually appealing, right? Somebody looks at them, they want to read them. They're easy to understand. So making tables, graphs, and figures is both art and science. You have to have both technical skills on how to do that, as well as some sort of artistic artistic uh, inclination to say, how do I make this appealing for a reader to see that. When you are, this is more of when you're categorizing variable, make sure that your information is comparable to some other report as well. If there are conventions for categorizing certain variables, you may want to use those. If not, if your data doesn't support, you may have to do something a little bit different, but look at how you can categorize your variables that is going to be useful when a reader is trying to compare your study to somebody else's study. Arrange the tables and rows in some sort variables in some sort of a natural order. Example I have here is smoking status, for example. So what you have here is a current smoker, former smoker, never smoker versus unknown, right? If you had former first and then current versus never, the reason we have some sort of a natural order here is current smoker probably likely to have the highest risk of whatever the outcome you're looking at, versus former is second highest, never is the third highest. So there's some sort of a natural order between those categories of smoking. So always think about, is there some natural order I can put these so that it is easier for a reader to make sense of what I'm trying to present. So I'm going to go through several examples of, how some of the things I'm talking about here in next few slides. So when you compare the statistics between two groups, it's always better to have them side by side. In this example, what I have in table 1 is, on the left, we have two groups, intervention group and usual care. So one group versus the other. You want to present the number of person years and the rate of disease list, right? So you have two ways to put those. One is number of person years for intervention group, as well as unit of usual care in one column, two next to each other, and the rate between intervention and usual care next to each other. that is a better way to present because you're interested in comparing the rates between the one group versus the other. If they are next to each other, it's easier for the readers to compare those numbers. Versus you could have done it a different way, which is shown in the second table where you have intervention group, person years and the rate, and a usual care group, person years, number of person years and rate. So you're going to have to go across 3 or 4 columns to compare two numbers. So those are sort of a little things you have to think about when you're presenting the result to make it really easy for a reader to understand. The other thing you want to do when you're presenting tables is should not have any vertical lines, no vertical lines, no more. Then you limit the number of horizontal lines, and then use the horizontal lines strategically so that it is telling something. Right? For example, if you look at the horizontal line, person rate, person year, intervention and usual care, it is basically saying person and rate applies to these both columns. So use the horizontal lines strategically to imply some important information, and no vertical lines, because we don't do vertical lines when you're reading across a table. If you have a vertical line, it kind of messes up the vision and you get confused. So you look at if you go and look at most journals, good journals or the reputable journals, you'll see a certain pattern. You won't see tables with vertical line, and there's a reason for that. Okay. So the other thing is numbers are easier to compare when tables have vertical orientation, right? Up and down, as shown here. The other things we have is I come across, and student come across is, should I report the row percentage versus column percentage? It depends on what is the purpose of what are we trying to convey. For example, in this table, what we have is two groups, diabetes versus non-diabetes. Let's focus on the last two columns, is a percentage, right? If I'm looking at these numbers, 15%, 16, 11.6, 25.7, all these this is the distribution of smoking status among diabetes versus non-diabetes, and same with non-diabetes. So I can compare, okay, the 15% of diabetes people are current smoker versus 18%. So that's what you're trying to compare. So it's okay. That's one way to report that. Sometimes you may be interested in, okay, what is the prevalence of diabetes among current smoker versus former smoker, never smoker? Then you may have to present the horizontal row percentage. So that's one of those things you have to think about. What is the purpose? What am I trying to present over here? So, but vertical orientation is always up and down is the way to go when you're presenting result. Right. When you are presenting the numbers, account for shifting denominator. What does that mean? Okay, if you have some missing data, not all the variables have add up to the total sample size. You have to make sure that those are accounted for in your tables. And if sex has, let's say your total sample size is 250, but you're missing information on particular variable, you only have 245 for that variable, make sure that the reader knows there are only 245 in that particular variable. Okay. Be consistent in appearance throughout the reports. Again, data presentation is both art and science. Okay. So this is an example of a table that from a paper published in American Journal of Public Health, again, highlighting some of the things I just talked about, starting with the title of the table is really descriptive. It tells you who, when, what and when is the demographic and resettlement profile of resettled refugee children younger than 18 years of age by blood lead levels in Ohio 2009 to 2016. It exactly tells you what you're looking at. You don't have to go any further. There are no vertical lines, and the authors have used a horizontal line strategically to mean something. For example, look at that, this horizontal line that spans 3 columns. That basically saying blood lead level, what's the frequency, what is the proportion, and that applies to all these 3 columns, right? The unit of measurement is specified, frequency as well as the proportions are reported, right? And note the decimal places, and this journal only wants 1 decimal place for both the odds ratio as well as and throughout the manuscript. So look at the logical order for the country of origin. The way the author decided was based on the alphabetical order, A to U, and then the other category country was the last one. All the notations are clearly explained. There's a asterisk over here, and then they tell you what that asterisk stands for. Again, right? So that's an example of how how to put a table and a table that is seems to be in a good book. So journals do not make tables for you. They actually, are going to publish the table that you create. This is basically the raw version of the table that you saw in the journal. If you note between this and the previous table, you're not going to see much different, except that the font is different than what the author submitted to the journal. So it is your job to actually give the table or figures in the format that you want to be presented. So that was the descriptive table. The table 1, the descriptive characteristic table, right? The table 2 and table 3, they can be sometimes combined, gives you the univariable and multivariable analysis results. Again, here what you have is the association between demographic characteristics, both the univariable, the unadjusted, as well as the adjusted, right? In the same population. Again, you have a descriptive analysis where they are reporting the prevalence. In the third column, they are reporting the univariable analysis result, whereas the prevalence ratio and the 95% confidence interval. And the last column is the multivariable analysis result. Okay. Note the consistency of the reference group that they're using. They decided the bottom one should be the reference group. So in each category is the bottom number, and the reference group is the last category again. All the notations I explained clearly. The other thing I was talking about earlier is how to present the percentage is illustrated over here. So if you look at the prevalence of prevalence is 24.7 for males and 19.7 for females. Looking at these two numbers, as a reader, I should be able to know this 1.2 is correct, because prevalence is basically 24.7 divided by 19.7, right? As a reader, I know. So I know that should be the correct number. So having these row percentage reported here is useful, because that's the purpose of this paper and the table. So always think about, when you're thinking about, what should I report and what is the purpose that you're trying to convey. Okay. So this is basically the table 2 and table 3. Some reports have these tables segregated. The univariable analysis segregated as table 2 and the multivariable table 3. It all depends what you are trying to present. So there's not a hard and fast rule. And these authors decided they wanted to include a figure, not because it was important to include, because if you look at the lead level between 1 and 6 years of age, it's the highest risk, and understanding what is happening between each age group between 1 and 6 was important. So that information was not presented anywhere else, so they decided to, put that information in a figure. Again, that was important. If that was not important, there would not have been a need for this figure. Again, figure is a self-explanatory. They have everything that you need to understand this table, this figure right over here. So a couple of 2 minutes, I'm going to finish my presentation with a couple of things that you are going to be learning in the next discussion section. So is when you're writing a paper, including result methods as well as the discussion section, make sure that you're avoiding scientific arrogance. What I mean by that is don't proclaim your result or your study is the best thing since the sliced bread. That means, oh, this was the most wonderful study. There was no problem with it at all. All studies have their flaws as well as their strengths. So talk to them, discuss them. Avoid verbosity. Then be concise and clear. Don't go on a tangent. Improve readability. That means be simple, clear, and concise. Again, this applies to result section as well as the next section you are going to be learning. And this is more for the discussion section, derive the appropriate inference or interpretation. So we'll talk about that this next week. So with that, I'm going to summarize today's presentation. Result dissemination is an integral part of research endeavor. You have to, if you do research, you have to analyze and report, disseminate the result. Effectively communicating findings to the stakeholder is important for why you're doing research. Know the key message being delivered and know your target audience. And when you are presenting results, it requires you to be both scientist as well as artist and use those both modalities. Thank you.
Thank you, Dr. Bhatta. So looks like we have about 6 minutes. If anybody has questions, while you're thinking of your questions, you can write it in the chat or raise your hand and you can unmute yourself. One of the things that I'd like to thank, besides Dr. Bhatta, is also our administrators. Arjuna, specifically Arjuna Pokhrel, who's done a lot of logistics behind the scene, and also Pratik Sapaudel, who both of them are at Tulikel Hospital, Kathmandu University. All right, with that, we'll take questions. If everybody is thinking, I can ask one for Dr. Bhatta. Because in tables, you'll see a lot of footnotes. Can you comment a little bit about, footnotes and whatnot?
Okay. Yeah, so first is if you don't need to have footnotes, if you don't need to put footnotes, don't, right? Sometimes it may sound like, oh, I need, a classic example I see is sometimes I have students doing, so OR 95 CI, then put an asterisk and put a footnote there. If you can put odds ratio and 95% confidence interval in the heading, then you don't need to employ footnotes. But if you have to employ footnotes, then if you can't put enough information for the readers to understand what you're trying to say in the body of the text, then employ the footnotes to explain what that the abbreviation might be or what that information might be. Okay. Avoid it if you don't need to. Don't put unnecessary. If you have to, then make sure it's explained. I don't know if that answered your question.
Yes. It was most for everybody. I think Sanjeev, did you have a question?
Or
You
Anusa.
want to unmute yourself and ask?
Yeah. Go ahead, Anusa. Anusa had that too. Or Sanjeev.
Yeah, generally what we have heard in house setting is that univariate analysis or univariable analysis is analysis of single variable presenting in either frequency percentage or central tendency.
Right.
And today we saw that you have given that the relationship between the variable. So can you make clear on that?
Yeah. Yeah, I know. It's even here, if you go to social sciences, other when they talk of universe variable analysis, is basically the descriptive percentage, the frequency and the proportion. When we talk about univariable analysis, epidemiology, public health, it's usually the association, one variable, one exposure to the outcome. But as long as you kind of know what you're talking about, it's okay. I know it's the semantics difference, but yeah. So if that is confusing in our setting, we'll call it an unadjusted analysis. I guess would be the other way. Does that answer your
Generally, we used to say the term bivariate analysis, you know.
Yeah, that they use in social science. Yeah, that's the distinction. But it's the same thing. We're saying the same thing, right?
Okay.
Bivariate is what they call univariable in epidemiology, and the descriptive is uh, the univariable, what you call univariable. They're the same thing. So, Manasa, you had a question.
Um, Thank you so for the informative presentation. So त्यो I'll go in Nepali.
That's fine.
सर त्यो हाम्रो उसमा चाहिँ सकेसम्म यो हरिजोन्टल लाइनहरू चाहिँ अभोइड गर्ने भन्ने कुरा आएको छ होइन अनि त्यसपछि त्यो धेरै जसो हामीले यो जर्नलहरूमा पढ्दाखेरि चाहिँ त्यो सिम्पल टेबलहरू नै प्रेजेन्ट गरेको पाइन्छ तर
Right.
इज इट अलवेज नेसेसरी टु प्रेजेन्ट इट इन द सिम्पल वे अर कहिलेकाहीँ चाहिँ त्यो जस्तै हामीले डिस्क्रिप्टिभ जस सोसियो इकोनोमिक भेरि उहरू डेटाहरू प्रेजेन्ट गर्दाखेरि चाहिँ त्यसमा त धेरैवटा नि हुन्छ नि सर बट त्यो भर्टिकल उहरू चाहिँ धेरैवटा नि हुन्छ त्यसमा
Right.
ग्रिड राख्दाखेरि इफेक्टिभ हुन्छ कि हुँदैन
Right. So the reason why you don't avoid putting grade is when you're looking through, going across a table, when you have a vertical line, it kind of distracts. It's hard to, it might seem like, oh, it's helpful, but it actually more not as helpful. So the other thing is each actually journal has a style that they do, but what I'm talking about in 90-95% practically I'd have to find an exception where they do the vertical line in normal journals. So
सोसियो
some journals use
डेमोग्राफिक
yeah, go ahead. Yeah.
सोसियो डेमोग्राफिक डेटाहरू प्रेजेन्ट गर्दाखेरि चाहिँ सर त्यो सिम्पल टेबल बनाउँदाखेरि चाहिँ अलिकति त्यो क्लियरिटी नदेखिने
Right.
जस्तो भएको हुँदा चाहिँ
Yeah.
त्यो भर्टिकल उसमा चाहिँ विथ ग्रिड्स इट इज ओके अर नट
The other it's the journal probably will tell you to remove those, right? So yeah, as I said, 90%, 99% reputable journal ma vertical line राख्दैन क्या. So when
अनि
you have
सर
a lot of information, right? You say, well,
या
there may be a lot of information associated. You're gonna have to think, is it necessary to have so many categories, right? That's the other thing you have to think about it. Is it useful if a category only has 3 or 4 people? Wouldn't it be better to actually consolidate some of those categories, right? So,
अनि सर त्यो उसमा चाहिँ फुटनोटको कुरा पनि भयो सर होइन
right.
इज इट अलवेज नेसेसरी टु पुट द फुल फर्म्स अर द डिस्क्रिप्सन्स अफ द युनिभर्सली एक्सेप्टेड एब्रिभिएसन्स जस्तै हामीले मेल फिमेल भनेर राखिराख्दाखेरि फेरि तलपट्टि फुटनोटमा एस्ट्रिक गरेर एम फर मेल एम फर फिमेल भनेर
You
राखिरहन
don't even
सक्छ
have to M for right? That's the other thing is you do not have to put the what the coding was in your data set because for example, my data set may have cat for male, I don't M for male or A for whatever. That's
Yeah.
meaningless. You put what is the actual meaning, right? You don't have to say M and F. Just say male and female. So you don't have to use asterisks, right? You don't have to say one equals male, two equals female, because that's why is that necessary, right? A reader doesn't need to know how your data was coded. They need to know what the inherent characteristics of that variable mean, right? So in fact, do not put the code in the how it was coded in the result section. That's not going to be useful. Your data set, you have coded certain way. I may have coded differently. So those are not the universally accepted, right? So that's one thing. The second is, do you have the universally abbreviation? Yes. Yeah. Don't abbreviate things that you don't need to abbreviate. But if you need to have an abbreviation, then explain that. Does that answer your question?
Other than the minimizing the number of horizontal vertical lines, are there other tips to make the clear figure and the table sections or trick?
The tip is do it 100 times. You start with, the way we start is, I said you'll have 3 or 4 tables, right? We usually
Yeah.
start with 8 or 9 tables. Then we start consolidating. Each table goes through, a lot of iteration. The table you saw that is one of our tables. I'm sure
Mm.
is in a span of a year or 2 years, that's done by Dr. Shakya. Sunita Shakya was my doctoral student, and we went through, I don't know, 20 iteration of that. So it's, in fact, it takes longer. Analysis takes shorter time now than actual presentation. How to make these tables and graphs and figure. That's
Mhm.
most time consuming aspect of
Mhm.
writing manuscript nowadays, not the
Yeah.
analysis. Now, you have computer can do the, write a code, 5-line code, give you multivariable analysis. It's not complex. Most of them, I'm not saying everything is easy, but what is time consuming is coming of the table. The final product is what takes a lot more time. So
One last question. Is the coloring it or providing some
avoid
small
shading,
color
yeah,
shading?
black and white, simple lines. In fact, you have the presentation that, that's how they end up present publishing. So don't do colors. In fact, they charge you more to, if you want to color something, publish a color. The figure you saw there, right? It's a black and
Yeah.
white. It was published as a black and white. If you wanted a color, put the color. They would have charged us $500 to, and there was no need for the to have the color. Color wasn't
Yeah.
adding anything else. So no, don't use shadings. Just minimize the number of lines. Keep it simple, clear. The point is you're trying to convey your information, your statistics and information, not how, you know, more simple and clear you can make it better purpose it is serving. Okay?
Thank
So
you.
let me chime in a little bit too,
Yeah.
because
So,
first of all, I think, Dr. Mandiku also wrote there. Yeah, you have for every journal there is a guide, author's guide. So follow that because it's very important to do that because certain journals will only allow certain number of tables and figures. So if you start with 9, you may need to learn to consolidate. The other one is if you have too many rows or columns, my initial gut feeling is that that's a supplementary table and not your actual table. And for supplementary table, you can put an Excel sheet too. Some of the journals will just allow you to put an Excel sheet. That's fine. The other thing is try to avoid colors, because like Doc said, they'll charge you. So what's the point of making, different colors if it's not necessary? Now, sometimes it might be very important, but even when you make a graph, you can do, dotted lines or lines with stars and pluses to distinguish the curves. So if you can do that, why not? Right? So there are certain, so some of these things we will talk on the fifth lecture as well as to, some of the things that's beyond your scientific kind of thing. What are the journals that you're looking at? How do you find the journals and those kind of things? But anyways, in the interest of time, I think we'll have to wrap it up because our lecture series is only for 1 hour. We're a little bit, few minutes after one. If anybody has any questions, please send it to us. We can also direct that to Dr. Bhatta. And our next series will be more on, I think he also referred to it, discussion. We will announce that in few days. So that will probably be about in 2 weeks, just to make sure that it's between Dasai and Tihar, so everybody has free time during that time. All right, with that, thank you all for joining. Thank you, Dr. Bhatta, for this very insightful. Every time I listen to these, I learn something new. So hope everybody has a great Dasai. Please enjoy with your friends and family, and then we'll probably see you in about 2 to 3 weeks on discussions. Okay, Dr. Bhatta, can you sit back while
Yeah.
everybody
All
signs
right.
off?
Yeah. Thank you, everybody. If you have questions, you know where to find me.